All right, let's dive headfirst into the absolutely incredible microscopic universe of nanotechnology. It's a world where the biggest breakthroughs are happening on the smallest scale imaginable. And today, we're going to zero in on the tiny, super powerful materials at the very heart of this revolution.
So, let me just ask you this. What if we could send out these tiny, microscopic heroes to, I don't know, hunt down diseases inside our bodies or build the electronics of the future from the ground up? I know, it sounds straight out of a comic book, right? But this is the very real and very exciting promise of nanotechnology.
And here it is. Meet our hero, the nanoparticle. Now, these things are just unbelievably small. But depending on what they're made of, gold, silver, iron oxide, they have these amazing, almost magical abilities. We're talking unique optical properties, crazy powerful magnetic fields, and incredible catalytic powers. They are, without a doubt, the key to so many of our future technologies.
Okay, so we have our hero. But you know how it goes in any good story? There's always a catch. There's a big problem. And for our tiny heroes, they're facing a massive challenge, something that's really holding back their true potential.
So here's the deal. On their own, these nanoparticles are, well, they're a little bit unruly. They're inherently unstable. They have this powerful urge to just stick together, to clump up into this big, useless mess. Scientists call it aggregation. So instead of a perfectly formed team working together, you just get a chaotic, jumbled blob.
And you have to understand, this is a huge deal. The moment they clump together, all those amazing properties we just talked about, the optical, the magnetic stuff, poof, they just vanish. A clumped-up nanoparticle is basically a superhero without their powers. It's totally useless, and this one single problem has been a major roadblock for years. But what if we could give our hero a supersuit, a really elegant solution that doesn't just solve the clumping problem, but actually gives it brand new powers? And that's exactly what scientists have done. They've come up with this super ingenious solution, polymer coatings. And yeah, you should absolutely think of it as a custom-designed supersuit, but on a molecular level. It's this tiny layer of polymer that wraps around the nanoparticle, protects it, keeps it stable, and completely changes how it behaves. And this isn't just any old suit. It's incredibly versatile. Okay, so job number one, stop the clumping. It does that brilliantly. But it also makes the nanoparticles stable and biocompatible, which is absolutely crucial if you want to use it in medicine. And get this, the suit can even be programmed. You can design it to react to specific things, like a change in pH, a shift in temperature, or even a flash of light. That unlocks all these new targeted abilities. Okay, so how do you actually build one of these incredible supersuits? Well, there are two main ways to do it, and honestly, they're both pretty clever.
So method one is called grafting 2. And the analogy here is perfect. It's basically like taking a pre-made suit, a polymer chain that's already completely built, and then chemically stitching it right onto the nanoparticle surface. The great thing about this is you have a ton of control, because you know exactly what the suit looks like before you even attach it.
Then you've got method 2, grafting from. Now this one is a little different. It's more like weaving the suit right onto the hero's body. You start by attaching these little initiator molecules to the nanoparticle. Then you add the basic building blocks, the monomers, and the polymer chains just grow right off the surface. What you end up with is a much denser, more uniform coating, a really tough, well-fitting suit.
All right, so our heroes are suited up and ready to go. Now for the really cool part. Let's look at some of the actual missions they're taking on right now, in medicine and in technology.
Check this out. This is a fantastic example. We have a gold nanoparticle, and its mission is to fight cancer. Its supersuit is kitted out with this special targeting molecule, and this molecule is designed to do one thing, find and latch onto these proteins called integrins. And those integrins, they're like these little flags that pop up all over the surface of many tumor cells. So yeah, it's basically a heat-seeking missile for cancer. And does it work? Oh yeah, the results are incredible. Because of this targeted suit, the nanoparticle can, and I'm quoting here, enhance tumor accumulation and cellular uptake. So what does that actually mean? It means the medicine gets exactly where it needs to go, building up inside the tumor while leaving the healthy cells alone. Pretty amazing.
And these suits get even smarter. For instance, you can design them to be pH responsive, so the suit holds onto its cancer-fighting drug payload while it's in your bloodstream, no problem. But the second it gets inside the more acidic environment of a tumor, the suit changes shape and releases the cargo right where it's needed most. It is literally precision-guided medicine at the nanoscale.
Okay, let's switch gears from medicine to tech for a minute.
Another amazing mission for our suited-up heroes is in the world of flexible electronics. In this case, we're looking at gold nanorods that get coated with a special conductive polymer, and this coating transforms them into this stable liquid ink, an ink you can actually print onto flexible surfaces, like highways for nano-sized electricity.
Now, the real magic here is that these inks are what's called sintering-free. See, normally, to make nanoparticle inks conductive, you have to bake them at really high temperatures. But that process would just melt anything flexible, right, like plastic or fabric. But with the right polymer suit, these nanorods become conductive instantly, no heat needed. This is a total game changer for things like printing circuits directly onto your clothes or onto flexible displays.
So, as you can see, the missions for these nanoheroes are just all over the map. You've got gold nanoparticles targeting cancer with those pH-responsive suits. You have silver nanoparticles using their natural antimicrobial powers to purify water. And you've got gold nanorods in conductive suits paving the way for flexible electronics. Every single hero and suit combo is custom-built for a specific, world-changing job.
So where is all of this heading? It's becoming really clear that the future here isn't just about the nanoparticle itself. It's about the absolutely incredible potential that gets unlocked by giving it the right suit.
And that, right there, is really the key takeaway. The polymer coating, that supersuit, is what takes these amazing, powerful, but kind of unruly nanoparticles and turns them into these highly specialized, precision-engineered tools. It's the key that lets us finally harness their full power to solve some of our biggest challenges in medicine, energy, you name it. What this really does is give us a whole new toolkit to work with. Our ability to send these microscopic heroes out into the world is really only limited by our imagination. So I'll just leave you with this final thought. With this kind of power in our hands, what massive global challenge do you think these tiny heroes should go out and conquer next?